Hey everybody, this is Larry. This is day 9 of the Advent of Code in the year 2024. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. On day 9, I finally, for a long time, I thought this was a camel. The art that's on actually the side. The ASCII art, I thought it was going to be a camel for some reason. It looks like a camel. Look, that's like the head. Those are humps on the right side. But now that kind of look at it again, it looks like a 10, the number 10, which makes sense because this is the 10th year. So I guess it's like a 10-year celebration thing. Also, thanks for 10 years of Advent of Code, Eric. If you're watching, probably not, but if so, still, shout out. But yeah, 1 minute to go. I don't know. I feel like these days, honestly, the beginning of the year, I was hoping to kind of finish top 100, maybe an outside chance, given all the large language models, which I just call ChatGPT. But nowadays, I'm just hoping to get at least one day of top 100, and that'll make me, I don't know, feel like I'm doing a little bit okay. But yeah, 40 seconds to go. So very excited. Let's go, go, go. And yeah. I don't. I mean, maybe I started the video a little bit early, but that's okay. I don't have that much to say. I did run 9 miles today, so I'm a little bit tired. I took a little bit of a nap unintentionally because I just kind of passed out. Hopefully I can do this. We have 10 seconds. So yeah, let's go. Okay. Breathe in, breathe out. 5, 4, 3, 2, 1. Go, go, go. Alright. I forgot to change, sorry. That would have been really boring video. Okay. Is it one line this time? It is one line this time. I'm slow, I'm slow, I'm slow. So, Looked at more than 9 blocks. Okay, whatever. I guess I'll just have to assume. What am I doing? Okay. No. Okay. a little bit ugly. Okay, but that's fine. No, it's not. I mean, it is, but also. Yeah, that's not right. Yeah, well, maybe I'm just not getting on it today. I forgot to increment current. Okay, that actually is right. I'm doing n-square algorithm, so that's why this is a little bit slow. Maybe I should have done it a little bit. Let me rewrite it. Okay, well. '85th, not bad. Okay, that was an n-square algorithm. I need to optimize for it, but whatever. It works. I didn't want to think about it. Okay, focus. What? Leftmost span of freeze. I did not write in a way that this is easy to do. And this part is going to be the same, I guess. But I don't know how to do it. Okay. Well, what I want is actually a count. Okay, fine. Okay, and then the spaces of I. Nope. If length of array before we insert it, is going to be equal to end of line of I. Okay. All right. So then now we put print spaces. All right. Let's verify this real quick. Okay, let's just keep to the example. Okay, so then 5 is 4. Okay, spaces, we start at 2 is 3. 3. I think I should have done this with an infinity array instead of a fake array. Okay, so for spaces, right? Okay, spaces dot keys. Okay, so sort of. So then now for key and so this is the index in which we care about for space, right? So current is equal to max. Oh, actually, nope. Current is already good. So start is equal to current maybe. Okay, so then now we want to see spaces if but then now you have to kind of figure out how to swap those out with spaces. So that is actually tricky. This is a hard one to do. Why not yesterday? Okay, so okay, fine. So something like this. So when you take a number away, what does that mean? We create spaces at that area. We want to keep merging as we can, maybe. Okay, I mean here we can find, right? So whatever, m for move. So then we have if count of m is less than or equal to spaces of k. Right, and then m is equal to, okay, so here we set m is equal to current, right? So we try it for then now spaces of k we subtract by counts of m. But what we want to do though is actually try to be too clever, Larry. I know. Let's just do it this way. I think I tried to be too clever, maybe. And this should have been array.pop. I think that would have made it fine. Actually, that would have been it. Yeah, okay, fine. Yeah, that would have been really fast. I wasn't thinking. Okay. Focus now. Okay, what I want to do, right? So if okay, then now I don't think I need this. Okay, let's just take it out for now. While j is equal to length of array and array sub j. Okay, maybe I plus spaces is equal to 2. So then now if it's It's gonna be 0. Okay, so now we have spaces, right? So then now we want to go to, we do want to do count, right? So m is 0 to current. Maybe we have something like while spaces is greater than 0, if count of m is then we look for it. This is going to be n square, I think, just because I don't know. So then now we have to kind of replace. Still replace function in Python. Replace array. Find and replace. Or is it just like? I guess there isn't. Okay, so that means that. Okay. Okay, so then now we want to say if array sub j is equal to m, then we set it to empty. Okay, and then now we go and then now we go for j in range of count of m. We do array of I plus j is equal to this should be m2, correct? I have to double check that. Yeah, I have to do some other things though. Yeah. If space is equal, I don't need this loop. I mean, this will always be greater than 0. So then now I have this. We don't need this. What did we run out? I guess we just run out. So while m is greater than 0, we have this case, right? Okay, if then we want to break. My code is all over the place right now. Okay, so for j we change it to, okay, that's fine. And then now I plus j is equal to m. Right, and then we break, otherwise we decrement by m. I don't know if this is good. Let's try it. Okay, so this is k. What is this k supposed to be? Why is it here? Oh yeah, I had it differently before. Well, this did nothing. Okay, so well, doesn't matter. And why doesn't it do anything? Okay, so I found something. Maybe. It's still doing stuff. Oh, this is a dumb loop. Or a dumb indentation. Still not working though. Why am I debugging? Why is this not working? Tell me why. 9. Okay, we didn't move to 9 though. Or maybe we did, we just moved it back. So I forgot about that check that I was saying, which is that if array.index of m is graded I and all these things. Okay. 10 is not a thing. If m in array and, well, I guess the other way around is good enough. Why am I so bad at programming? Yeah, what am I doing? Paste the wrong thing. No. Array.index. Okay, so that's mostly good except for 8 is wrong. No, is it wrong though? 9, 2. We moved to 2. Wait, why do we move to 7 before we move to 2? I did it wrong. No. I did it in the wrong order. I was looking at the wrong thing. Okay, fine. Not to be. This is the wrong code at all. This is not. I spent so long on this. Okay, silly Larry. Okay, so then I have to figure out. Okay, so do right. So if I this makes me sad. Okay, so okay, so you have a while m is greater than 0. Have to be. Dang it, Larry. Silly Larry. I read that so wrong. Okay, so then now okay. Okay, so then now we have array.count of m, which actually we already have, so we have to find count spaces. Right? Whatever. If the leftmost that fits, right? So else space is equal to 0. Okay. Then now, if spaces is greater than or equal to R, then we want to move it to I minus spaces, I think, right? So we want to move it here. So then now we write this code in theory. This isn't that bad, but I read it wrong. Okay, so we moved it over. It's going to be for j is equal to is actually so we did, this is the first space in which we have enough is I, so it's actually I minus j, I want to say, but maybe I'm off by 1 here. That's not right. I did some really crazy nutty thing. Okay. I minus j, and then yeah, and this is only if r is less than. Oh, well, yeah. Why did I move everything to the right? I don't even know if this is right, but definitely not Gucci. Okay, that's not great. Print. I'm too slow because I misread it, amongst other things. but at least we got one thing, so that's fine. M, we kept moving. We have to break Larry. Okay, maybe that's mostly right. The 111 doesn't make sense. Oh, we moved the 1 even though it doesn't have to move. Okay. How would I check that? Okay, how would I check that? Okay, so if well, just check that you've seen it, right? So if array sub I is equal to M, we just break. Okay. Okay, I think we are good. So now we could copy paste to check something here. Though way too late because I misread the problem. It's okay, I guess. Right, oh, because it could be space. Okay, ooh, yep. Print out too much. Oh. Well, this is gonna take a while. But that's okay. I wonder if I could have done it a little bit faster, but we're already 3,000. We're already 40% done. Are these problems done already? Yeah, so I'm already missing it by 10 minutes, really, honestly. So I misread the problem, so I was really slow. I guess I could have trimmed a lot of these. How do I? Oh, here. Yeah, I mean, I think I'm fine with that. I mean, I mean, it's still not great, but it's fine. This is my code. So how long did this take? Let me not print stuff every time, and then let me. I'm curious. So we're work on optimizing it, but I'm gonna take a quick 10-second break. We did get on the board finally, so yay! But part 2 I misread. I did the wrong problem. You could when we go over the code, you'll see that I misread it. That's the TLDR. Because once I read it correctly, I don't actually remember my timer, but I thought I did okay. Maybe not super fast, but not that slow as long after I read it correctly. Because I think if you allow yourself to do n squares, it's not that bad though. It's more not that bad if you use a language that's not Python, I think, but I was just being dumb. I think I could have done that one much faster. Alright, let's go over the problem real quickly. Yeah, I mean, I think there's probably like a smarter way of doing it. I actually, if you recall from the video, I actually submitted this with an O of n square algorithm for the part 1. You can reduce this, and I already did reduce it because I just kind of bugged at me. And this is it. And the idea here, and I actually don't need the queue. Yeah, I actually could have just taken the last character, right? And that would be it. Let me double check that it works before I say that. Yeah, and you can see that it is much faster. I do print out things for debugging reasons, which we can remove for a quick second. But yeah, so that is pretty instantaneous. I'm pretty happy about that. But yeah, but basically it's just, this is for parsing it, and then this is for just getting the last character, right? If it's a space, then we pop it off the last character, and that's it. I didn't know how to implement this cleanly, but apparently I did fast enough. And the checksum, pretty straightforward. Top 100. Let's go, let's go, let's go. Finally on the board. Part 2, as I said, I just misread it. I thought I was supposed to go for every space, move the biggest, or maybe not, just move like the biggest ID thing that I could. So you could see that I did this here. I just wrote the wrong code. I mean, I wrote maybe the right code, but for the wrong problem in either case. But I knew that this was also n squared, by the way. So I knew that I have to wait a little bit. And the solution that I have now, and also the beginning part of this, we also just kind of pause. And just to be clear, there's nothing that I do that's crazy about this part. It is just literally what... yeah, it is just... it is just the thing that they tell you. I had like you just do what the directions that they give you. Sorry, I'm mind blanking for a second. But I mean, I did add a count thing just to make it a little bit easier. And here, this is an n square algorithm. For every m, I go through the array, or maybe even. Yeah, I mean, yeah. So this is n square at least, maybe even m times n times n. I mean, this only happens once, so even though this looks like an n square inside here itself, it actually isn't, because this only happens once and then we break, right? So yeah, so this is n square, m or m times n, which should be n square-ish. And I had this really ugly thing which never happens, I think. Maybe it does actually, but I just kind of skip it anyway. But yeah, so, and how long does this take? Oh, and the checksum code has not changed. So how long does this take? Let's take a look. I guess I left the printer statement there. I mean, I think it takes like quite a, because it's 10,000. So 10,000. I don't know what the size of the array is. So maybe we'll run it afterwards. Just check. So while that's running, here's another window. How many characters is it? I guess it doesn't tell me. Maybe print length of array. Did I not? Oh, I guess there's another print statement afterwards. I guess I print a lot of stuff. Where else am I printing? Huh. Oh, count is a matrix thing, that's why. So actually, so there's 100,000 elements. So I guess that's why it's so slow. But it still takes only 30 seconds, which, if I had read the prompt correctly, it's not in, like, you know, it's faster than I could have optimized it properly. I mean, I could have done smaller optimizations, which we'll try to do a little bit. First thing is noticing that, well, the I is always incrementing. Is that true? No, that's not true, I guess, actually. Because you could have smaller spaces in the beginning. Okay. I mean, I think you could probably... Yeah, I don't know if I can optimize this part. But, and then just move it out. Can I optimize this to be way smaller? I mean, you definitely could use, like, smaller data structures with, like, I don't know. Let me think about it real quick. I mean, because for every m, you know what the size of the m is. I think the problem is, I mean, it's not that hard. Actually, it's relatively straightforward in concept, but I would never do this during Advent of Code. Is that you can actually, it's just bookkeeping, right? You keep track of all the spaces. You maybe keep it in like a sorted list or whatever it is, some sort of smart data structure, and then you can do a very quick lookup of all the indexes of all the spaces, and then you just kind of go there directly, right? I think that's how I would think about it. The tricky thing is that when you move a number, you create new spaces. So that's the tricky part. And kind of like, and then so you have to do like manual merging of like, okay, here's our previous index, and then you have to merge it with the left space and the right space, just to make, and then get a new thing, which is, again, conceptually not hard, but very easy to make silly mistakes. So I would never do this during I would never do this during Advent of Code unless like n is like something ridiculous, right? Like maybe if it had another, because basically our code right now is 10,000 times 100,000, which is why it took 30 seconds. But I don't know, maybe if there was another factor of 10, but then maybe I would just use another language, honestly. I think Python is probably not suited for this problem for that reason, necessarily. Or like the way that I write it, not that Python itself. And I could never get PyPy to install on my Mac OS for whatever reason. So you definitely could do it. I think that may be even the intended way, but I wouldn't do it during. I mean, like we can do it afterwards, but I would never do it during the time to sell because it just didn't make sense. I mean, this still took me a long time, so maybe, and I was kind of still debating doing it the other way, so maybe never is a strong word, but that's how I would think about it. But I think everything else is just bookkeeping, right? So you could do something like, yeah, so, yeah, okay. Let me copy it to like, maybe we can upsolve this a little bit, but I just want to make a copy of it. For example, you would maybe write here, you know, you could keep track of spaces. Oh, that's part 1, so you wouldn't do it in part 1. But you have to, change on change, okay. Okay, so then maybe you would have spaces, you go to, right, project of list, and then now you would have spaces at, length of array, which is the yeah, so maybe s is equal to the int of lines of I, right? That's the number that you get from the input. And keeping in mind that actually I think one thing that I did miss is that there can only be 9 spaces in the beginning anyway, so maybe that's actually not true. But yeah, you we append the current index, which is the length of the array actually. So that will give you all the indexes of all the spaces of length s. So then now for this m, you already know how many things you do. You can maybe even do a binary search. I mean, I didn't do this that well, but because you can actually like just keep track of all. Like you have to do another thing to kind of get the next biggest space, right? So then maybe you could say available space. This is equal to like a sorted list or something, right? And that will allow you to write something like available spaces. We want to add s, and the reason we want to do that is that now for m, and let me just comment out this code, this other code that even though it works, is that okay, well we still have the same style code of like while m is greater than 0, we want to right, and we want to make sure that if count of m is greater than 0, otherwise, well, if is equal to 0, then we just document and continue, we skip. Otherwise, then you can do a, what is our sorted list, available spaces dot bisect left to get the available to get count of m. This will give you the next available thing. Though I guess there are only 10 space, up to 10 in the beginning, and even with merging, it doesn't get that much bigger. So that maybe you don't even, maybe this is too heavy machinery. But if you're talking about complexity, that'll make it slightly cleaner. So then you bisect left to get the index, right? So now, yeah, so the index is equal to this. So then available spaces of index is the length that you're looking for, the length of the spaces, and then you would have spaces of L, the first entry. So this should not be a list. This should actually be a deck, right? So then pop left is going to be the index, right? So this is the first index to fill, right? Something like this, right? And then now you can maybe, you could do it in a number of ways, but maybe you could just fill it in like, okay, now you do, which is similar to what we had before. Then now first index to fill plus j is equal to m, right? We want to convert the thing to all the previous m's to whatever. So we want to do something like this as well. Maybe you could also do a delay, maybe a delay, but yeah. And then now though, right? I mean, this part so far is still relatively straightforward, but then now you have to figure out, and this is the, and I think you just have to add more bookkeeping. But now you go, okay, well, now you have to. I'm not gonna write this code because it's. You know, these things start at 12, so I have to sleep. But then now the way that you would do it is that find the original index of m. Actually, I guess we do it kind of here, so you can maybe just add that here, right? But also, this does not need to go through the entire way if you were smart, so maybe if you had to keep track, then you just have to do where it goes off, right? But find the original index of m, where m is the current what's it called? What do they call it in the vocabulary? Whatever the whatever that we're looking to replace, and then maybe and then if you kind of keep track well enough, then you have to find the spaces to the left, find the spaces to the right, and then merge, update count, update available spaces, right? So oh no, no, you don't update count, sorry. You update spaces, update available spaces, and then that's your invariant, right? And then now after all this, then everything will be self-consistent. Again, not that hard conceptually, but there's just a lot of machinery and also very easy to make silly mistakes, at least for me, and I know myself, so that's why. But in that case, then you, especially if you kind of remove this, then you should be able to do this in linear time, just because everything you do, for every character, you only touch it once if you're smart. If you do it like very carefully. Even here, right? Like this is not right in the sense that this should have been like find the original index of m. So then this would start at the original index of m and then like counts to m or something like this. Actually, this is a little bit off, but you actually do a range of right? And then this would be j plus original index or whatever you want to call it, and then that'll be true. And this will always be true in that case, so we don't even have to check for it technically. So you have something like this, right? Again, the rest I'll leave it up for homework, but that's it. Yeah, I totally just misread and misunderstood part 2. As a little bit of a retro, it's one of those things where I honestly I underestimated the difficulty for this problem, and I don't even mean it as for myself. I mean it in a meta kind of way, in that it turned like I had more time than I thought I did. So when I rushed it and made a mistake on the reading, I actually like did not need to do that. I think that's the part that I mean, that like I thought it was easier. Well, I mean, I don't know. Both, like I thought it was easier than I thought it would be, if that makes sense. Or I thought it was easier than it is for other people. Maybe that's the better way of putting it. Like I didn't expect to be top 100 in part 1, honestly, as well. So maybe I could have like slowed down a little bit, make sure I read it correctly, because I think I got the actual code pretty quickly. Like this part is the actual code. It's so I don't know. So and even if you add in 30 seconds, like I had like about 8 minutes to finish this, right? I think 8 minutes was very reasonable if I read it correctly. Even if you take account like 3 minutes to read it, it would have taken me, I don't know, a couple of minutes to write it. I don't know. Maybe it would have been close, but either way, I should have been able to do it. Yeah. That's all I have for this one. Still, you know, I mean, anytime you get on the leaderboard, especially these days, not going to be too sad about it. Part 2, I just misread. It is what it is. It happens. When you have 25 days, 50 parts, misreading is part of the thing. It's just that you hope your good parts will carry the misreading and the dubious parts, which for this advent of code year, maybe not so much for me. So I don't know. But still, happy to get points. Happy to kind of get on the board for first time this year, finally. And yeah, that's all I have for today. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.